In the second part, write down two relations for the current in the circuit. Two relations from the circuit diagram. What are the two relations? They are talking about that you have to write the relation between what I1, I2, I3, I4, how they are related. How they are related, children. So you can write that one equation that I told you. Look carefully that this I2 and I3, when they're combined together, they are giving result I4. So it means this I4 is equal to the sum of I2 and I3. That is they are talking about in this question, children. Write the equation or write the relation for current. That the current I4 passing in this arm is sum of the current of I2 and I3. This is the first one. You need to write one more relation of current, and that current you can write what is another relation, children? That the battery has produced the current I1, and how much current is going back. If you see here, this is the same current that will go back. You can write that I1 is equal to I4. This is the second result here.
So can we also say that I1 is equal to I2 plus I3?
Yes, you can say that I is equal to, because at this point the current I1 divided into the two currents I2 and I3. So you can write I1 equal to I2 plus I3, and I know that, and children, I2 plus I3 we have taken, that is equal to I4. So what is I2 plus I3? That is equal to I4. That is the same relation. In any way, children, you can write again. We have the same relation, I1 equal to I4. Next part, and write down two relation between a relationship for the voltmeter reading in this circuit. Now you have to look for the expression for voltmeter from this circuit diagram. What you find, voltage. What are the two expressions for voltage? One I can find here, in the parallel combination, voltage remains same. That this voltage reading here, it is V1. And if you look carefully, look at the V4. This V4 is how it is connected. One terminal of the
Series.
voltmeter is connected to the one end of the power supply, for the positive is this side, and negative side is connected with the other terminal of the voltmeter. So it means this V1 and V4, they are in parallel combination. And if they're in parallel, so I can write that V1 equal to V4. This is my first equation or first expression of relation. I need to write one more equation. One more equation, children. And what equation I can write here? Children, that we already calculated that the total equivalent resistance I have in the previous diagram. You can see I have drawn that the equivalent resistance, this is 3/4. So it means that this V2, just suppose it is connected here. Okay, just forget about this part. So I have taken a combined resistance which is 3/4, and across this we have a voltmeter which read V2. And now this voltmeter, sorry, this 3/4 resistor and 2 ohm resistor, they are in series. And we know in series that the voltmeter reading V2 is different with the V3. V2 is different with the V3. So even you can also find that V2 is greater than V3 or V3 is greater than V2. They're not equal. But I can understand that it is surely that V1 is equal to the sum of V2 plus V3. Is this clear, children, that the voltage in the series combination, even though the potential It remains different across each resistor, but their total voltage, total potential difference is equal to the sum of the total voltage. So V is equal to the sum of voltage V2 and V3. So that is the two relationship in this question. Do you want to ask anything from this part, children? 10th class, boys and girls?
No, sir.
Question 6 we are not doing for the diode one. This one also not doing. Now come to question number 7, children. The circuit of figure 4.1 is set up to run a small immersion heater from a 6-volt battery. A heater is there, variable resistor is there. State the name and purpose of component X. Name and purpose. Tanuj and Atharva Chavan. May I know what is the purpose? What is the name of this component X? Atharva and Tanuj. Purpose of X and name of X. Okay, Karthik.
Sir, the
Sir,
resistor.
is it a variable resistor?
Tanuj,
And
wait a minute, Karthikeshai. Tanuj, please, you continue.
Sir, the resistor.
You said a resistor. Resistor, writing resistor, it is not the perfect answer. Resistor is only when you find this type of component. This is called the resistor resistance. But when you find a arrow, crossing arrow, so that is called a variable resistor. Variable resistor. So variable resistor means you can increase or decrease the resistance. So what is the purpose of or the benefit of connecting this variable resistor? So you can increase the value of current, you can change the value of resistance. Children, you can increase the resistance, you can decrease the resistance. By increasing or decreasing resistance means you can increase or decrease the current in the circuit. By increasing or decreasing the current in the circuit, then what happens with the heater? How does heater will work? Heater can give more heat, less heat, depending upon the resistance or depending upon the how much current is flowing. So basically the purpose of this component X is to change or to vary the value of resistance or current in the circuit. Now in B part, the heater is designed to work for a 3.6 volt supply. It has a power rating of 4.5 volt at this voltage. Calculate the current in the heater when it has the correct potential difference across it. Look at this statement, children, carefully. Heater is designed to work from a 3.6 volt supply. The total voltage is given 6.0 volt. Heater can operate it only if the voltage is 3.6 volt and it has a power rating given 4.5 watt. Calculate the current in the heater. Please take some time, children.
1.2.
So now in this question, many students I have seen they make a mistake. It is given here that this heater will operate on a voltage of 3.6 volt. You need to take this voltage 3.6. Power is already given, so you need to calculate the current. So we have equation P equal to voltage multiplied by current. This implies I you can calculate by putting the value of power, which is 4.5, divided by the value of voltage, which is 3.6. And if you do this calculation, you will find, if you do the further calculations, you will get 1.25,
1.25.
and you are calculating current, so the unit should be in ampere. 1.25 ampere current will flow and across this heater, across the heater, children. Now, what about the next part? And the next is second, calculate the resistance of component X if there is to be the correct potential difference across the heater. The battery and the emitter both have zero resistance. Okay, you need to calculate the resistance of component X. How would you calculate resistance of component X? Now it's very simple, children. It's very simple. How would you find? You need to calculate what is this resistance X when the switch is on, actually connected, and the current passing through the heater is we calculated 1.25 ampere. Resistance equation you will apply R equal to voltage divided by current. I know what is current. Current is 1.25 ampere. Both the X and this heater are in series, so the same current will pass through the variable resistor. But what is the value of V? What is the value of V? Now, here students make a mistake. What is V? What is V here? Yes, Anirudh.
Sir, is it supposed to be 6 volts?
No, 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 no. How it is will be a 6 volt? Are this X and heater, they are in parallel?
Oh,
They are in series combination. So even you look at this diagram, children. Suppose I have connected this X here. This is the variable resistor, and this is our heater. Okay, this is heater, and then I know this is the 6 volt. So the voltage across it will be different, and the voltage already across this heater is 3.6. We have calculated, but we know, children, that the total voltage V equal to sum of V1 plus V2. V is 6, V2 is 3.6.
sir,
You can
the answer
calculate
is 2.4.
6 minus 3.6.
2.4.
2.4, you need to put this voltage. Now many students, they write here the value V 6 volt, and in that situation your answer will be considered wrong. So voltage divided by current, you please divide it.
1.92.
Okay, if you are saying 1.92, so 1.92 ohm is the resistance of this variable resistor.